Welcome to a lecture series on data structures. In today's lecture series, we are going to see about tree data structure. So far, we have discussed about linear data structures in our lecture series. So from now onwards, we are going to discuss about nonlinear data structure. So first nonlinear data structure that I'm going to discuss is about trees. So before going into our topic technically, let us discuss about how a normal tree will look like. So this is how a normal tree will look like. It contains a root. It contains a stem which is called as the trunk. It contains leaves, twigs, branches, and fruits. So imagine this tree upside down. That is, you imagine you tilt this tree and imagine. So root will come at the top, and all the leaf branches will come at the bottom, right? So this is how a general tree look like, and imagine the same tree by tilting it at upside down. So this is how the tree will look like if you tilt it upside down. Uh, Now, how this is how it does look like, right? So now like compare this with the tree data structure we are going to discuss. So this one is going to be a root node, and these are the branches. At the end of branch, we have the leaves. So same is applied for the tree data structure. A tree will have a root node. From root node, it has several leaves, and at the end of each leaf, it has it from root it has several branches, and at the end of each branch, it will have leaves. So here, consider a tree. So tree is each here A, B, C, D, E, F, everything is called as nodes. All the data or information will be stored inside a node. So a tree data structure is defined as a non linear data structure or hierarchical data structure. It contains a finite collection of nodes. So the nodes are finite. It is not indefinite. And each node in the tree data structure holds a parent-child relationship. So it is a 2D data structure. So where do we apply tree data structure? So let us take this example. It is the electronic purchase history of US. So this electronics act as the root node. So to each root node, we have other nodes such as from root node, we have four different branches. So four different branches points to R&D, sales, purchase, and manufacturing. So these are the internal nodes. So except the leaf nodes, remaining all the other nodes are called as internal nodes. So let us discuss about the three terminologies here. The first node in the list is called first node in the tree data structure is always called as root node, and for a tree there will be only one root node. So here P is a root node, and the line that is connecting two nodes here between each node. Say for example between P and Q we have a line. This is called as the edge, which we literally called as branch in tree, and two nodes having here if you see take two nodes P and Q. P is a parent of Q and Q is a child of P, so that you should be clear, right? So two nodes having same parent are called as sibling nodes. For example, if you take the subtree containing nodes Q, A and B are two nodes which has same parent Q, so A and B are sibling nodes. And in any part of tree inside a any here if you take QAB, it is a subtree of entire tree. So a tree is collection of more than one subtrees. We can define it in that way also. A node without any children is called as leaf node. So if you take E, F, G, B, H, I, and C, D, these nodes do not have any children. So these nodes are called as leaf nodes. So if you want to determine the height of the tree, from the root node till the last leaf node, the number of edges is called as the height node. Here the last leaf is E, F, G, H, and I. So here the number of edges is 4. Maximum number of edges. We should take that way. So maximum number of edges is 4. Hence the height of the tree is 4. And so these are a few terminologies that we use in our tree data structure. So, what are the advantages of tree data structure is that it holds a child sibling relationship, which is easy to identify the values, and it reflects on our data structural connection, and it is very efficient when it comes to insert and search operation, since it supports the hierarchy. These are the main applications of tree data structure. If you take a file system, for example, inside C drive, we have desktop folder. Inside desktop, we have some other folder saved, and inside that folder, say for example, there is a folder called as X. Inside that X folder, I have saved a document like a.doc. So all these things are organized in the form of tree data structure. So this one we call it as a file system, right? So it is organized in the form of tree data structure. And dictionary is again the words in the dictionary is organized in the form of tree, which helps in efficient search process. And in case of network routing, the paths, all the paths in the network routing protocols are organized with the help of tree data structure, which makes the search operation more simpler. So these are the main applications of this is not the only application of tree data structure. These are the main applications of tree data structure. Apart from this, we do have several other applications as well. So here is a small assessment. So consider this tree. So here you are supposed to circle all the leaf nodes and put square box around the root node. So let us find what are the leaf nodes here. So as we have discussed earlier, node without any child is called as leaf node. Here the nodes 1, 3, 7 and 40 do not have any children. So these nodes are called as leaf nodes. And for any tree, there will be only one root. There can be more than one parent for a particular tree. But when it comes to root, there will be only one root. So here the node 14 is the root node. So what is the other question is draw a star around each ancestor of the node that contains 10. So what are the ancestors of 10? It is 11 and 14. So you have to put a star x through every descendant of the node of that contains x. So the descendant of 10 is only 7. Only one node descends 10. So you put a x near 7. Clear? And these are the various sources from where tree data structures are referred. Even you can make a note of it in the next lecture series. So here in this lecture we have discussed what is tree data structure and what are the various terminologies we will use in tree data structure and its application, and we end up the session with one simple assessment. In the next lecture series, we will discuss about tree terminologies, representation of trees and types of trees like general tree and binary tree. And again, under binary tree, we do have several other classifications. All those things we will discuss in the upcoming lecture series. Hope you understood this topic. Thanks for watching.